AEC collection customers can use a combination of AutoCAD and Revit-based deliverables with BIM 360 docs to deliver accurate documentation for all project members. In this workflow example, a structural precast detailer has an existing library of AutoCAD details that he would like to leverage on a project that requires Revit. Using BIM 360 docs, he can collaborate with Revit users on the required precast designs and communicate all necessary precast connections in the DWG file format. The AutoCAD designs can be leveraged by Revit users when modeling LOD 400 in the BIM environment. These details can be attached to the final documentation too. Revit is a BIM-centric solution for the reinforced concrete industry to connect concrete design and detailing to fabrication. It provides tools for detailers for modeling 3D concrete reinforcements, creation of shop drawings, and bending schedules in the advanced BIM environment. The structural precast for Revit extension provides Revit users access to powerful tools for automatic rule-based segmentation of precast structures, automatic reinforcement, shop drawings, and CAM files. The structural detailer can use the Publish Settings tool in Revit to select views and sheets of the model and publish them to the cloud. Once all 3D precast designs and drawings are created, the structural detailer can share them with the project leader via BIM 360 docs. Once all published views and sheets have been extracted, they are ready to be reviewed by the project leader. BIM 360 docs integrates the entire project workflow from design to construction across one common data platform. In this first case, reinforcements around the door opening need to have a greater diameter. To ensure that any errors found in the review process are addressed, a trackable issue, complete with a detailed description of the problem and a recommended completion date, can be assigned to a specific project member, in this case, to the structural detailer. The second issue points out that there are missing grout tubes in the precast wall. The third issue identifies missing reinforcements around the opening. BIM 360 docs can also create markups. When a user adds a markup, it is added to the document's markup history. It can be tracked by the revision history as the team responds and adds additional markups. By default, markups are private, but they can be set to publish via the Markups panel and seen by all project members. In our example scenario, a precast detailer received an email notification with a link to the issue that was assigned to him. This link instantly brings him to his BIM 360 docs project and to the right view. The viewer is automatically zoomed into the issue pushpin. He can get a very quick understanding of all issues that should be addressed. Fixing issues with Dynamo and Revit is very useful. In this case, the structural detailer is using Dynamo Player within Revit to automate the process of adding tubes to the precast walls. Once the updates or changes are completed in Revit, the structural detailer can respond to the project leader, using that same tracking tool that keeps an up-to-date record of the issue's progress. Confirmation of the issue's resolution can be done by using BIM 360 docs' Compare feature that visually highlights exactly what has been modified. BIM 360 docs has integrated change visualization that lets users compare the changes between two selected versions of the project. The summary provides a quick accounting of the changes contained within the new version of the project. The number of changes within the list may vary when filters and search criteria are applied. BIM 360 docs users see color coding that shows how information has changed. The added, removed, and modified buttons act as a toggle to hide or show the results from the list. At this point, the issues can be closed, and the issue's history is kept in the BIM 360 docs environment, where everyone on the project team can see who was involved in its resolution.